last presentation, we're going to continue the trend on AI now. So thank you so much for joining the session, for hanging on for the last keynote of the day here. So as Margot mentioned, my name is Christine Sarros. I'm the Senior Vice President of an organization called our Oracle Enterprise Engineering team. The use of AI is, top of mind for most of us these days. Whether we're building AI into our own products, we're consuming its functions from products we buy, or we're practicing a bit of both through integrations, it's really important for us to really think about defining our intended outcomes. So in my session today, what I'm hoping to do is discuss some key generative AI concepts. I have some slides for you to show you some graphs and other things that will hopefully help you with some visual aids. And I'm hoping to introduce you to several internal use cases that we've deployed within my own organization with the objective to really aid senior leaders and, really folks across the industry, set yourself up for a successful AI journey. So as we begin, it is our corporate policy. I just want to quickly convey our safe harbor statement. So the content I'm covering today is informational, and it's not any sort of formal commitment by the company. So as we get started, I just wanted to share just a little bit about my experience with technology and why the subject is so near and dear to the heart for me. So as we've talked about, I've been working in the technology industry for 25 years. I actually started my tech career as a software support tech, answering the phones and the help desk. And now I run a 1,500-person global organization of engineers and operators who are driving strategic product innovation every day around the company, which is just really exciting. And at Oracle, very specifically, consuming AI as part of our employee experience is actually my responsibility. It's a big responsibility, very important responsibility. So whether this entails using Oracle's own AI, embracing embedded AI in the products that we consume from other companies, whether those are third party or others, or whether we're using some sort of hybrid model where maybe we're using some of our data integrating to other company systems, et cetera. My team and I have spent thousands of hours, literally thousands, maybe more than tens of thousands of hours, researching and implementing a lot of these AI services before we deploy them to our internal employee base globally, who are using it as part of their daily business workflows. And I think that's really what this is all about is how do we begin that journey, and how do we really start with what are the things we can start with out the gate. And the last thing I just wanted to quickly say is I believe the decisions we make now are, especially as we're considering large data sets across nearly all of the industries that we all participate in, need to be thoughtfully based on security and privacy models. I truly believe that artificial intelligence has a power to transform our worlds. And if we use it collectively to drive positive outcomes by understanding the basics, we're going to have that much better results with the things that we design and deploy. So quickly on my agenda, I just have three kind of general sections that I will discuss with you today. So first, I'd like to introduce just sort of some of the background and basic concepts behind generative AI. Then I'll discuss how we're applying generative AI here at Oracle within my team and how we're leveraging some of the Oracle products and other capabilities. And then I'm going to finish my talk with just a quick summary for you of some good AI practices, which hopefully will help you build your own AI solutions. So as I'm sure that you have heard about many times today, if you've been listening to some of the presentations as I have, the topic of AI is there's just so much excitement around it in the industry as large. I want to set the baseline with sort of defining generative AI. Interestingly enough, autonomous generation of new text was available in the 1960s in the form of chatbots, if you can believe it. And then we had a lot of early first generation machine learning capabilities. And a lot of those things were focused on structured data, often working with numbers and giving us the ability to do things like predictions, classifications, and finding ways to not only recognize patterns, but to operationalize things against them. And an interesting example of a sort of early AI application was sorting the mail in the post offices by recognizing handwritten zip code digits. So lots of very powerful techniques, still very relevant today. But generative AI itself, it's really new and different. And what it brings to the table now is models that can actually create content that looks and feels as if a human had created that content. Could be something like email. It could be, writing code, creating videos, many applications. And these models are getting much larger. They're getting really powerful, and they can do all kinds of interesting things. But there's sort of two distinct characteristics I wanted to talk about in particular with generative AI. One is sort of the generative function. That's its ability to create things based on patterns that it's seen you train on large sets of data, and then leveraging those observations or learnings from those patterns to create content based on it. The other part of it, also significant, is the generalization component. And that's based on those patterns. It can be asked to do things or to create content that's new and not like something it's seen before. So it can generalize that data itself to create new content. So what's really exciting is this really rapid adoption of AI. On this graph, which you can see here, I've got time represented as on the x-axis, and I've got US users on the y-axis here. Is AI usage is outpacing even PC and smartphone usage in the first 4 years of adoption, like true adoption, which is crazy because everybody has a phone, right? Most people have PCs. So we're seeing even more the quicker accelerated pace of adoption than those products. So from an industry standpoint, say things like the service or sort of hospitality type industries, it's becoming increasingly crucial to incorporate this technology just to even maintain competitive edge and to evolve products and services. But what businesses need or enterprises need are really models that reflect business outcomes. These are models that can be really fine-tuned, adapted to a specific organization's data, specific data being the key word there, and designed to deliver secure, fast, and relevant outputs that support business outcomes, which could be providing that automated service or simply providing an automated report that allows a human to make a data-driven decision. And this is sort of a lot different than what you see in some of the consumer spaces where, some things are consuming just general internet data as a whole. So with all of these advances in adoption and capabilities also comes a rapid influx of investment, with an expectation that AI is going to contribute $16 trillion, that's with a T, to global GDP by 2030. But let's take a step back just for a minute and just really understand exactly what is going on with generative AI. Let's look behind the curtain and let's really understand sort of the magic that's happening behind the scenes. So let's start with the data. So we have a variety of data out there in the world. Maybe 20% is structured, things like database records. And then you've got a whole lot of unstructured data, things like text, videos, social media content. These are big opportunities if businesses can figure out how to use all of these millions of points of data. So to process this data, AI represents them as vectors. And these vectors allow us to understand the relationships, the underlying relationships of the data. And the vectors are used to represent the semantic content or the meaning of those items. So in this 3D graph that I have represented here on the right-hand side, my graph is considering features such as age, gender, and royalty. So in this particular example, queen and princess are semantically close. They're both females and they're both royalty, and they have similar representations. Same thing, we're sort of king and prince on this chart. So at its core, a vector is a sequence of numbers known as dimensions, and the dimensions are designed to capture the essential features of the data. And these vectors are generated using deep learning embedded models. So we take this knowledge and we sort of use this concept of data representation, and we leverage the entire web to build data AI models. We can think about large language models. LLMs are models that are trained on the large internet corpus, and they crawl public data that exists in the public domain, things like Wikipedia, social media data, or general web data, web pages on the internet. And these models can do some really cool, neat, interesting things. For example, they can pass a bar exam, and they can write term papers, and they can do relatively complex tasks like comparing two philosophers and their philosophies. Or they can simply just give you a bit of information, a bit more contextual information from things you used to do with just a general Google search in the past, as an example. But here's the thing, the most important thing. Most businesses are not trying to write term papers about philosophers. They're not likely to ask questions on the general internet and the huge corpus to make critical business decisions. What businesses are looking for are models that reflect things that are specific to the business. They're models that can be, again, fine-tuned or adapted to that specific data and look or feel like they're very relevant. So at the end of the day, generative models recognize patterns and embeddings to understand language and to predict things like the next best word in a sentence. And it may sound kind of complicated, but it's actually pretty simple. The main thing that you really have to understand is that generative AI works by using embeddings. And these are those vector representations of your data. So the better the embedding model, the better able the model is to work on language problems. So the question everyone's asking is, okay, great, that's nice, I understand the science, but how do businesses actually use this to use AI and use these concepts to leverage these models? And so, as I mentioned earlier, businesses are not looking to just go scrape the internet and use all of that data to run their business. Enterprises need to use these models in a very trustworthy way that provides data privacy and protection against things like data leakage, bias, hallucinations. There's a lot of innovation in this space, including the idea of retrieval augmented generation, or RAG. The general principle is that generative AI is great, it does amazingly cool things, but it still has limitations, things like hallucinations. And hallucinations are just what you think they are. They're incorrect or misleading results. And those incorrect results reduce the reliability of your behavior accuracy. And so RAG is a specific method designed to resolve that. And what you do, very simply, is you take that model and you connect it to a database or some sort of source of trusted knowledge. You then let that model query and pull back this retrieved documents as to be used as part of its response. And what that really does is it gives you a few things. The model then is citing known trusted knowledge sources, which is improving your context and your reliability of the response. And the model is also relevant. It has relevance to the known private knowledge that you define. And equally as important, it's kept up to date. So you're not pulling data that could be published at any particular point in time. It's just as relevant as the way that you're pulling the data and the data that you're providing it. So by using RAG to incorporate your specific domain and your enterprise data, the results become much more useful to you as the recipient of that data. So now that we covered, sort of the basics, high level, let's put all these pieces together and just take a look at a very simple, simplified Gen AI workflow. So starting on the left-hand side of this slide, number 1 here, the user is issuing a query. That query is vectorized and it's passed to this vector DB we talked about. In step 2, the vector DB is processing the query and it's looking to find the closest proximity results to the question that was posed. In step 3, the user's input query plus the results obtained from the vector DB are passed to the LLM, which generates the answer. And finally, in number 4, that final answer is sent to the user. So this approach, known as the RAG approach, is an excellent use case when you're doing things like QA, chatbot, summarization, semantic search to find the best answer based on this enterprise data that you've associated to. So my next slide here, my intent, sort of shifting gears just for a moment, is just to highlight why it's important to define your use cases before you designate your solution. So for enterprise use cases, you've got different types, different sizes of LLM models are available, which depend on the order of magnitude of the parameters that you want your model to really consider. So on the left, you have a small or medium-sized LLM models, which have orders of billions of parameters as a potential, which require a smaller hardware footprint and are often more cost-effective if you're looking to just get started and you don't have trillions of parameters to consider as an example. And they also may have some lower latency in some cases. On the right are for these really large models that have trillions of parameters. They're a lot more powerful. They require a larger hardware footprint. So you've got to make sure that whatever you're using, whatever systems you're using behind the scenes that are powering that LLM are highly tuned and account for things like latency considerations. So the net here is really for enterprise use cases, not only is it important to consider, the way this all works and the LLMs, but it's important to consider cost and latency as far as which LLM you're looking to actually choose. So again, we've talked about the basic concepts in the models. So I want to talk about a couple of key use cases for enterprises. So the first is summarization that I'll talk about, and this is really creating a summary of original text. So it could include things like, bot, please summarize my project document, my legal contract, a policy, potentially. Semantic search is, instead of using just keywords, it's really aiming to understand more around the meaning of the query, that semantic context of the query. RAG is this model that improves the relevance of responses that you can layer on top of that. And then chat is really, allowing for interactive conversations with our users to solve, simple to complex problems. I'm going to jump into a couple of things that we've done here at the company. So a couple of the use cases where we've already implemented a Gen AI with a RAG model is with our internal enterprise search, as well as our search on oracle.com. Our AI service desk, which is something that supports all of our internal employees for AI service, and then our smart contact center virtual agents. So I had a nice little video here on the left-hand side, but PDFs didn't work for that. So my apologies for that. But I've got just a snapshot here for you of my Oracle, which is our main intranet site for Oracle employees, which allows access to all internal resources. It receives 5 million hits monthly from our employees and enables employees. It's sort of like the main landing page for employees for access to any and all internal content related to anything employees need to do to complete their daily jobs. And one of the most important features of this portal is something we call My Oracle Search. And what that is, it's an enterprise search service. And in that service itself, off of this page, gets 500,000 queries per month. So we used to use a lexical search to retrieve the results from our enterprise search. To improve relevance, we moved from this lexical old sort of search to a semantic search, which allowed employees to get more relevant results. And we saw about a 65 to 70% click-through rate on search results. And we also received 75% in positive feedback from the users on the quality of the generated answers. And we're just getting started. The other thing that you may not be able to sort of see on this slide is with RAG, we've also combined the semantic search with LLMs to provide a simple summarized answer. So you don't have to click through and just get a whole bunch of links, click through this link, read this thing. Instead, we're actually summarizing the most relevant answer and providing that in a very crisp, clear response, which actually becomes conversational. And if it doesn't answer the question or if it requires a next step, we have the opportunity to then take an action for the employee to say, click here and we'll make this change on your system, et cetera. So much more conversational again in nature than just giving somebody a link or just giving somebody sort of a flat response. The next scenario I want to talk about is our AI service desk. So this is, the customer support scenario is common to likely all of our industries. All of our support today is done through a chatbot. Our old bot was a rule-based system that matched keywords and provided initial answers from it. And as a result, unfortunately, because we didn't have great knowledge behind it, in many cases, more than 90% of our bot engagements resulted in tickets that actually needed to be passed through. So what we were able to do is we invested in Gen AI, we built this AI service desk, and we were actually able to clean up our data and provide accurate step-by-step solutions to user inquiries. And thus far, we've just been live since February on this. We've seen ticket deflection rates of 20 to 30%, meaning at 20 to 30% of the things we used to have to pass through before are no longer being passed through because we're actually providing the right information for either the employee to solve the problem themselves or we're solving it for them through the bot. And we are anticipating a further 20% deflection by the end of May because we're doing a lot of model tuning, which is an important part of this, right? You've got to start somewhere and then you've got to continue to tune the model as you go along. Moving along, so we've had all these applications built on top of our Oracle AI stack. And so I just wanted to provide a quick bird's eye view of it and just to illustrate that we have capabilities that range from infrastructure to data platforms to a number of AI services. And one of the key differentiators that I'll just quickly mention is all of these things are integrated now with our Oracle SaaS applications. So if you're already using some of the Oracle SaaS applications as part of your portfolio, many of these AI services I'm talking about are already, part of that. So just something for you to consider. In addition, to accelerate building AI applications, Oracle is going to be releasing very soon a new managed service called the OCI GenAI Agent Service. So it's a fully managed service. It actually automates the end-to-end process. And it includes the whole process from understanding the user prompts, the data retrieval that we've talked about, and taking necessary actions. So the retrieved data itself is actually used to trigger execution of the contextually correct action in this case. So in this example I'm showing you here, the user query is booking a flight, and it's processed with the final output being the confirmation of the booking itself. So this is a nice option, whether it's the OCI service or some other service. It's a nice option for enterprises who are looking to go to market for AI, but maybe you don't have all the in-house skills to make it happen, or you don't have the time. There are managed services coming to market in this space. And then if you're interested in building your own models from scratch, say you really, you have the time, you have the skills, you've got, some great ideas or a use case that's very, very unique, you may want to consider OCI superclusters. They provide one of the highest performance and lowest cost CPU cluster technologies in the world, with really great networking, large local storage, and bare metal compute. So with that being said, I think I'm just about out of time here, so I'm going to quickly wrap up soon. So I just wanted to say, Gen AI provides an excellent opportunity for enterprises to deliver on their key scenarios like search, support, contact center, as well as many other cases that you have. Realizing this potential requires adoption and execution of good AI practices. So I'm just going to call it a quick few. So when you're building your product, you want to carefully derive your end objective and how it supports your business goals. Use data that is representative of your scenario specifically, and keep it updated to ensure the models work well in practice. You want to set up introspection and visualization tools to understand the data pipeline, and you want to make sure you understand that end user experience. Regarding the people, it's critical for you to identify the key stakeholders who have domain knowledge, customers who use the service, and to have diverse groups of testers who are representative of your broader use cases. The more diverse, the better to consider your use cases. And you want to set those feedback loops to continually learn from your user experience so you can drive the right improvements in the right areas. And then from a technology standpoint, you want to leverage the right foundation, like understand the foundational models, leverage the right foundational models, or consider managed services from cloud providers and fine tune them with your data. There's lots of options out there now. What's most important and imperative in the technology space is ensuring that you understand the data security and privacy of anything that you're using. And then you want to do continuous analysis and monitoring to ensure that your model is performing well throughout its entire life cycle. So to close out here, I've got a couple of resources that I'm providing. My email, our product lead email, are also included on these slides if you have interest in any of our products in particular. I'd like to say thank you so much for your time today. I've really enjoyed the session, and I hope you're able to collect maybe even a few snippets of information that will help you along with your AI journey. It was a pleasure to discuss AI with all of you today, and thank you for your participation.